is Jennifer Erica.
And my name is Tanij Natividad.
We are grade 10 students from William International School, Maputo, Mozambique, and our project is about the effectiveness of biofuels. Today's society is very dependent on the use of fossil fuels, which are both environmentally destructive and very expensive to refine. Due to these problems, it is evident that an alternative fuel source is required. That's why I bring it to you, chachofa. Chachofa is an excellent substitute for petroleum and diesel-based fuels. It is more affordable than the traditional fuels and has a minimal impact on the environment. Searches for fuels such as this have led to the use of ethanol, which is commonly manufactured from corn seed. The use of corn to produce fuel is now being questioned both ethically and economically. It is a great food source that is now being used to produce fuel, thereby reducing the amount of consumable food for the population. Chachofa is not only a good replacement for traditional fuel, as it is for corn, plus it costs less. However, corn is not the only option of producing fuel. Chachofa is looked upon as a miracle plant in the biofuel industry. It is inedible as food source. This means that it can be consumed in manufacturing of biofuel without altering the food supply.
Jatropha is a general term for a genus, not a species. This means there are many different types of Jatropha in the world. There are nearly 175 known species of Jatropha in the whole world. The manufacture of biofuel out of Jatropha first requires the production of Jatropha oil, which can be achieved using Jatropha crocus, which is a tree-like bush that gives fruit, and the fruit is poisonous, making it unconsumable. Jatropha can grow in harsh and arid environments. This makes it more usable and versatile in places where almost nothing can grow. The seeds of this plant are said to be made up of 40% oil. This means that 2,000 barrels made of a single square mile of Jatropha would give us a price of $43 a barrel, which is less compared to the price of crude oil. The process of oil extraction out of Jatropha can vary greatly, but their main basic steps are universal. First, the plant needs to grow and mature in about 5 years. Then it can be harvested and the seed will be grown to a thick powder. The oil is filtered and the waste product can be used in the production of other materials.
As I said before, Chachofa is an excellent substitute for petroleum and diesel-based fuels. It provides energy independence for the countries that need to import oil from major countries. Now they can grow and harvest their own Chachofa oil. It will allow countries to reduce their expenses in crude oil. This means that they will now be focused on healthcare and water purification. Many job opportunities will become available. Therefore, the local and national economy will greatly improve. Burning of Jatropha is much cleaner than petroleum. This means clean air and a minimal impact on the environment. Burning Jatropha emits almost no chemicals and very little carbon dioxide to the atmosphere.
The purpose of this experiment was to establish an alternative source to diesel fuels, to substitute traditional fossil fuels with an economically reasonable and environmentally sustainable biodiesel through the synthesis and analysis of synthesized Jatropha and canola biodiesels.
Materials used for this experiment were Jatropha, canola, lye, methanol, scale to measure mass in grams, beaker, burette, Erlenmeyer flask, and a thermometer. First, 50 milliliters of methanol was measured and poured into the 250 milliliters beaker. Then 1.50 grams of lye was measured and added to the methanol in the beaker. Then the solution was mixed for about 15 minutes till the lye had completely dissolved. Then the solution was poured into the 250 milliliters Erlenmeyer flask. Then the solution sat overnight to allow separation. Then biodiesel in the surface of each flask was poured into each the respective burette, and then sat overnight to further refine the biodiesel.
5 million years of each potential fuel source was added to the independent aluminum pots and respectively labeled. The time the solutions took to ignite was recorded and observations were noted. The burning solutions were allowed to burn for 1 minute to confirm results, then smoothed with an aluminum sheet. 100 milliliters of Jatropha biodiesel and canola biodiesel were added to these pots. Then 100 milliliters of water were added to the 250 milliliter beakers and placed on rings over the pots. Small wicks of tissue paper were placed on top of the pots and were allowed to soak for 1 minute. Both wicks ignited and the timer initialized. Observations were noted including the temperature change in the water in set intervals of 7 minutes until the fire was out.
Observation: formation of biodiesel. Here we can notice that the Jatropha and canola oil were liquid, transparent, yellowish-orange, more viscous than methanol, and had a moderately strong odor, while the canola oil had an odor similar to diesel fuel. Time before ignition. can see that the raw oils did not ignite. This means that it did not undergo combustion, while the biodiesels did ignite and underwent combustion. The canola biodiesel took 50.1 seconds to ignite, while the jatropha biodiesel took 47.8 seconds to ignite. This means that the jatropha biodiesel is more effective than the canola biodiesel. Energy reduction of biodiesel. By these two charts, we can see that the jatropha biodiesel is more effective than the canola biodiesel in terms of temperature change and heat produced.
In conclusion, our experiment was a success, and our investigations proved that jatropha and canola biodiesels are both good substitutes to traditional diesel fuels. But jatropha is more efficient than canola biodiesel since it ignited faster and it produced more energy.